We are multiplying lots of things here, 1 plus a half and so on. And we just need to be careful. So remember, this is the third term. And in the third term, the last number is one more than the term number. So we just keep on multiplying them. And we're interested in the smallest value of n, the number of terms for which the nth term is an integer. Now I'm going to have to go onto a separate line. But how do we know whether to multiply these two things and we're going to get an integer? Well, the key thing is actually to start adding up the fractions. 1 plus a half is actually 3 over 2. 1 plus a third is 4 over 3. And 1 plus a quarter is 5 over 4. And it might be at this point that you kind of start spotting that there's a pattern. The thing on top, the numerator is always one more than the denominator. So the next one would be 6 over 5. Because I'm just going to be adding 5 over 5 to 1 over 5. And that would be true for any of them. So if I do 1 plus 1 over n, then it's going to be n plus 1 over n. So you can be pretty sure about that. Now, we can bring these inside the square root. When you're timesing things, root a times root b is root ab. So I'm going to get 3 over 2 times 4 over 3 times 5 over 4 times 6 over 5, and so on. Okay, and I'm just going to keep going until I get an integer. So the 3's are going to cancel, the 4's are going to cancel, the 5's are going to cancel. And by the way, I should probably say, before I start cancelling them, that if I just had two terms, then like forget about these ones. At this point, I'd have root 2. That's not an integer. That's why I need to then look at the next term. The 4's are going to cancel. Now I'd have root, so forget about that one. I'd have root 5 over 2, which is not an integer. So I'm going to need to keep going. These are going to cancel. Now I've got root 3. It's getting larger, but it's not the case. And you might be able to see at this point, right, I got root 2, then I got root 3. Root 4 is the one that I actually want. So the next one is going to be 7 over 6. 6 is cancelled. I've now got root 7 over 2. No. Here, 8 over 7. Right, that is going to work. That is going to be root 4, which is equal to 2. And I've got 1, 2, 3, 4, 5, 6 terms if I just count them. Because this one here is actually going to be the square root of 1 plus 1 over 7. Remember at the start we said that the number of this here is always one more than the term number. So the answer is, is going to be 6, and we're going to get 2. Of course, you could carry on if you get more integer solutions. One other way you could do this question would be to notice that when you times it together, right, you could actually write down the nth term overall, because it's going to always be, we're always going to be dividing by 2, because that one never cancels. And remember, for the first one, we had 4 over 2. For the second term, we had 4 over 2. For the third term, we had 5 over 2. It's always the term number plus 2. So we're actually interested in where this is an integer. I'm just giving you an alternative approach. And this is quite nice actually, because it will tell you other answers that are also integers. So you can see when n is well, we need n to be 6 to get our next one, root 8. And the next time is going to be to get root 16, and it's going to be when n is equal to 14. So that will give you 4. So you basically, you can keep looking at the terms in the sequence that will be integers. But the first approach works fine. Just cancel it out until you kind of, you get it to work, and just be careful and get the term number.